Hi, everybody. Welcome to Byte Ventures, where we deep dive into the marvels of technology. In today's case study, we'll discuss about the project Logback, its efficiencies, its performances, the architecture that goes behind making it one of the super efficient Logback project ever made. So without further ado, let's dive deep in. So a little bit of overview first. So Logback is a successor to the log4j project, or which is the famous log4j project, and it is designed by the same founder, Ceki Gülcü, in the same project. Logback has much faster processing time, much efficient computations, and is a very smaller footprint in comparison to its older counterparts. It provides some kind of unique and useful features which were either missing or not effectively available in the older counterparts. Okay, so what are the requirements? So Logback, if I would give a little bit of context, so what exactly is a logback? So logback is kind of a logger, and why do we use loggers? So logger is used by developers or programmers to log certain things from the application they're running. This could be used for debugging applications, to track metrics and all stuff. Okay, so for that, logback needs to have certain requirements, and this is this. So the logback class should be added as a dependency to your primary application. Mostly we're talking about Java application here. So it requires an lf4j jar, and it requires a logback core jar and a logback classic jar. So whenever we are installing the logback module, it combines all of this different logback hyphen jars. So that's why this is put together. So this is available together as a single package, and slf4j jar is a separate thing which needs to be installed or added to the class path for the whole logback thing to work in efficiency. Okay, let's take an example of what a log looks like. How do we add a log, and how do we make sure that this is actually working? So this is a basic sample of a program. We have a Java class which we have defined as a package. We have a bunch of import statements, and this is the class which is hello world 1, which is defined inside the chapters introduction package. We have this main function, obviously the arguments passed over here, and this is the main crux, right? So we have this logger, and we have defined this logger by the logger factory.get logger. So logger factory comes from slf4j that we have added as an added dependency, and we have defined that the name of this logger should be chapters.introduction.helloworld1. Don't worry about all of this information. We'll get to know what all this exactly means. So this logger has something called as debug method. For now, let's assume that it's a print method to kind of print some kind of information. So in this case, we are trying to print hello world from this logger or using this logger. So the output of this program looks certainly like this. So there are a bunch of information which are pretty important, and we'll talk about how they are coming in the first place. But the most important thing that we are talking about is this place. So this logger helped us log hello world to the place where we want it, right? But you might be thinking that what are these actual other additional information like this and all stuff? And how is this getting routed to the right place, how it is getting formatted and all stuff? We'll talk about that. So for now, just remember that logback adds a default console appender to the logger. So it kind of formats this into sort of a console based format, and it kind of have some kind of default layouts for that. And that's how all of this information is getting popped. Okay, but you might be having a question like, how do you verify that it's using some kind of default configurations that we have not provided? Or you might be hiding something because you have just provided a single line of code, right? Okay, we'll answer that question. So let's have the exact same functions with an added internal state printing. So here logback provides a way to print its internal state that kind of like what are the sequence of events that happen before we reach this. So this is the exact same thing that we did with chapters.introduction.helloworld2, but this time we have changed our class from 1 to 2. That's a difference. And similarly, we have named it this way. So there is a way, or there is a standard to name the name of the logger as a fully classified name of the class. That is why you're saying chapters.introduction.helloworld2. That is like the standard that is being followed over there. So we have the logger, same here, but we'll have some kind of additional prints print statements rather. So we have the status printer. So status printer is provided as a utility, which is useful in certain cases to debug things. As in this case, will help to prove the point that it's kind of using some kind of default configurations or default printers to print it out. Okay, so look at this. So ignore all of this first place, but look at this place. So this is the hello world that we're talking about. So this is the exact same thing that we have from the last example. And there were some other things. So look at this. So it could not find resources, logback.groovy could not find resources, logback test.xml could not find resources, logback XML, and default configuration is here. That means what we can figure out from here is setting up a log or setting up a logback instance requires some kind of configurations which needs to be powered through as well. So that configuration can either be provided by a Groovy file, which is a logback.groovy, or a test, a logback test.xml, or a logback.xml. In this case, none of these are available in our application, and hence the logback took the default configurations and appended the console appender to just print out the information that we have. And that is why we're seeing the bunch of information that we have, right? There is another catch. So in case of errors, in case of not able to do anything that is expected, this print, the status printer or the internal context printer gets printed by default without specifying this print command. So just keep in mind. Okay, so now we have talked a lot about appenders, like console appender. What the heck are appenders, right? So in other words, we can say that appenders is like a destination, output destination, I would say. So it's like a class which can be an output destination in this case. And it exists for many different destinations, including the console. And that is how it is named as console appender, files, file appender, syslog, syslog appender, TCP sockets, JMS, and many more. We'll see this in a bit more depth in the upcoming part of this video. So before moving to this, let's dive deep a little bit about the logback's architecture. What is present where, and where does this collect together to give a whole rounded picture of the things. So there are three modules in logback's architecture. So if we talk about this, we have a logback core module, we have a classic module, and we have an access module. So logback, if we talk about that, we have three modules. And if we talk a little bit in depth about the logback, it has three different classes, which helps us do all the things that we are planning to do as a developer, like log things, write it out in a specific format, or roll things out in a specific format, and all stuff. So the three main classes are the logger, the appender, and the layout. So we talked about logger, right? So logger is the basic or the main class, which is responsible for all of the things. The appender is the output destination. It provides like where I should write this logging information, and layout is something which is providing the format of what exactly it's writing. Because in the last example, we saw that we just typed hello world, but it took a lot of other state or other information to put it in there, and it added a whole string for that case, right? Okay, so there are this information that we have just discussed. Okay, so we can say that this logback is stitched to this logback classic module. So the logback's architecture has three primary modules: the classic, the core, and the access. So this logger is attached to the classic, and the appender and layout are attached to the core. So there are some other information that are accessed to logback access. Not a scope of this video. Probably we'll cover it in some other parts. Okay. So now there is an obvious question. These are a lot of complications, right? We have to select a logger, we have to select a configuration file, we have to give an appender, we have to give a layout file. So why not use the infamous system.out.println in Java or similar in other languages, right? So the main thing is, if someone uses system.out.println, there is no way you can control whether you want the system.out.println or not. That means if you have put a system.out.println, or sysout, I would say for short, that has to get printed. There is no way you can skip that. But in certain cases, you are very concerned of the things that, okay, this is not useful anymore, I just need to turn it off. So for that, what you need to do is change the application, remove the sysout line, make another deployment for all of the nodes present in your production environment, right? And that's a pretty expensive way. And if you have to do things in and out to debug things, you have to make a release every time. That just makes the whole process so much inefficient. So to solve this of the cases, the logger comes into rescue because this gives the developer a control at runtime to log what all things they want to log, what are the formats they want to log in, and what is the output destination that they want to log this information to, right? And that's makes life much more easier. You can just turn off certain kind of things, you can turn on certain kind of things, you can specify that, okay, this should go in this path or this directory, or this should write into a remote location and whatever. Awesome. So let's talk a little bit about hierarchy of logs, right? So we have discussed about loggers, so let's go a little bit in depth about some of the hierarchy that we have. So loggers, as we have discussed, needs to have a name, which is generally recommended to have a fully qualified class name, but in this case they're case sensitive, right? If you are writing foo.bar and you are instantiating a logger in this case, and foo.B the bar is two different instances of a logger, they have to have same name if you're trying to reference the same kind of logger. And obviously, as they're case sensitive and we're discussing hierarchy, they have certain hierarchical rules that they follow. So for example, foo, if you have defined, so logger.getLogger, and inside that you have defined foo, and then there is another logger.getLogger with a foo.bar, we can see that foo is a parent of foo.bar, exactly like other languages or JSON or Java, whatever you talk about. Similarly, foo.baz will also be a child of foo, right? That is pretty obvious. So as it is a hierarchy, it kind of brings us to the obvious question of a tree-based hierarchical structure, right? Like for me, tree comes to the mind directly. So if there is a hierarchy, if there is a parent-child relationship, there should be a someone which is at the root or the top of the tree. So in this case as well, there is a root logger that sits at the top of this, which is called as the root logger name, is defined as this constant. So whenever you want to access this, you can go through this way. Okay, so there are other levels of hierarchy as well, which are defined or tied to printing methods. But for now, just see that these are the 5 different levels that we have. Like we talked about hierarchy, but this is a different kind of hierarchy. So I've kept it in the same position because this is kind of like someone is greater than this, someone is greater than this. Not actually hierarchy, but a specific order, I would say. So we have trace first, we have debug, we have info, we have one, and we have errors. Okay, so this is certain things. We'll come back to it once we go forward. Okay, so that we have talked about hierarchies, how can inheritance stay back, right? If you have talked about object-oriented programmings or coming from a programming language background, you know that with hierarchies, we have inheritance in place, right? So let's talk about how the inheritance works. So the print methods that we discussed last slide, like the trace, the debug, the warn, the info, and all stuff like here, these define the level of the log request. Okay. So if a given logger has no level, that means it derives the state or the level from its parent. It goes up. And for each one to have a default configuration at the end, so we have to have a effective level. So this whole thing, or getting the information or getting the level from its parent, has to be called the effective level in the context of loggers. So to avoid any kind of lack of information or not available thing, we have defined a default level for the root logger, which is the debug. Okay, so if that means if any of the logger doesn't have it, they will inherently have the root logger as their parent, and the parent will have a level of debug which will get assigned to this, and that's how it is working. Okay, let's see some examples in this case, right? So in the left first column, there's a second column and there's a third column. The first column is the logger name. So in this case, it's root. It's by default assigned a debug level, and the effective level in this case is debug as well. Coming to the next part, we have X, which is another logger. It looks like it doesn't have a parent, but root is the parent of all loggers. So when we have X, the assigned level, we haven't assigned any levels to this, so it is none in this case, but root is a parent. So that means debug comes to here as well. Similarly, x.y is a child of x. So this will go up finding levels until it finds a not null value, right? So it has a none, that's why it is also debug. And similarly, this is also debug as well. Okay, well and good. Let me know if you have any questions in the comment section. Then we have this root logger again. We have assigned level as debug is effective. This is pretty straightforward. Coming to X, now we have assigned a level. So when we have assigned a level, it doesn't need to go to its parent to find the level. That means its effective level will be info as well in this case. And the third, coming to x.y has no levels. So it will go to its parent first, which is x, has an info level. So this gets assigned to here. XYZ has assigned level, need not go to its parent. The error level gets its effective level for this case. Okay, so it doesn't need to go to the root always, and that's how it defines. So root is pretty obvious. So X is assigned info, the effective is info. X.Y has no level, so it will go to its parent, info gets assigned, and similarly x.y.z, info gets assigned. I hope things are pretty clear by now. Okay, let's move forward. Let's see some examples to make sure that our understanding is correct or not. So I will just write the sequence before we try to solve this puzzle. So we have first as trace, then we have debug, then we have info, then we have warn, and then we have errors. Okay, let me just confirm it. Okay, info, warn, and error. Info, warn, and error. Okay, awesome. So these are the levels. That means what is the effective level? We'll take an example to know what exactly is the effective level used for and how is this pattern will be helping us solve this case. Okay, so we have defined this logger, which is of name com.foo. That means this logger is basically com.foo logger, and we have set the level info. Okay, so when we have this, just ignore this for now. So coming to this and this. Okay, so whenever we have a log.warn statement, this is like a print statement. We are requesting a log to be logged with a condition of warn. That means we are wanting that, okay, we want a warn kind of logger. So that's why we have printed it. So this request will be accepted only when this is greater than equals to the level that is set by the logger. I'll say it again. This logger.warn will get printed only when warn is greater than equals to the level set by the logger, right? That means we have warn here. So warn comes greater than info in this case. That means this will get logged. Debug. So we want the debug to happen, but debug comes here. So debug is lesser than info. The level of the logger is info, but the request is of debug. So this will not get logged. That means even if this logger is present, we'll not see a log line or a print statement having starting search for nearest gas station. We'll not have this example, this statement printed in the logs. Okay, so these are done. Let's come to bar logger now. So we have bar logger or bar L, I would say. So bar logger is coming from com.foo.bar. That means this is com.foo and this is com.foo.bar. So this is basically a child of com.foo, right? That means whenever there is no levels present, it will go to its parent to get it. So you see bar logger does not have a level that is being set, right? We didn't have any level set. So the default level for this case will be info, because it will fetch this from its parent, right? So let's evaluate these two statements. So when we have this, so it has info and bar logger dot info is this. So should this statement get printed, located nearest gas station? It will, because info is greater than equals to info. So this will get printed and logged effectively. And we have debug. So debug comes lower, it will not get printed. I hope things make much more sense in this case, and that is how log request is enabled or disabled in the runtime. This is not possible, by the way, using system.out.println or whatever the print methods that we're using, language specifically. Okay, so there is one little information that loggers, when called with the same name, the exact reference of that is returned. So we don't need to pass the exact logger if we want to have the exact or the logger to act in the same context, right? So if you're like having two functions and that is defined in two specific classes, you don't need to pass that whole thing from just a minute. So you cannot pass the whole information from, you don't need to pass the information from one class to another whenever you need to pass the information. So we call that information by the same name, it'll get it, right? Repeating, just to clarify, okay, sorry, just to clarify, when we have to pass the logger from one class to another, we don't need to pass any kind of reference. So if we just specify the same name, we'll get the same logger back as a reference. So if we'll do logger.log, it'll do the same attach appenders, layouts, and all stuff. Okay, so enough on the logging levels and whether it's enabled or not. We'll talk about appenders and layout a little bit more, right? So selectivity, we talked about selectivity at runtime. That is one part of the picture. So now the other part, of the more important part, is talking about where does that output goes in, what is the format of that? And for that case, we have appenders and layouts. There is one thing that we can attach multiple appenders to a logger. That means whenever a logger is activated, we'll say that fan out this request to multiple output locations or destinations that we have. And that is how it will be used in that case. And the second thing is the hierarchy comes in to appenders as well. So there is a field called additivity. So if additivity is not equal to false, or if it is true, then the logger has the parent's appender as well. That means we'll get to see some more examples, but just keep in mind that if additivity is true, that means it has to honor the parent's appender as well. Okay, let's take an example. So we have this root logger, or the name of the logger as root, and we have that appender as A1. So in this case, when we have A1, and of course the additivity flag will not make sense because this is a root logger, we have the output targets getting outputted only to A1 for now. Then we have defined another logger which is X, and we have attached two appenders, AX1 and AX2. As the additivity flag is true, it has to honor that it has to take care of A1 as an A1 as an appender. So the three output targets in this case will be A1, AX1, and AX2, right? That should be clear. Then we have X.Y as a logger. So X.Y is a child of X. It doesn't have any appenders, but it has additivity flag is true. That means it has to honor all of the targets that its parent had. That means it will be the same as this case, A1, AX1, and AX2. Coming to the next example, we have XYZ, and this is the child of XY. It has an attached appender of AXYZ1, right? And we have the additivity flag is true. That means whatever is the parent, it has to take in, as well as the new A.XYZ1, right? And that is how it is. Now the security is attached appender of asec. The additivity flag is false, so it will just take its own appender, nothing else, as output destination. With security.access, we have attached appender, no attached appenders. The flag is true in this case, so that means it will take whatever its parent has. It has no appenders for itself to attach. It will go with a.sec. I hope this should make sense by now. If you have any questions, please let me know in the comment section. Okay, so now talking about layouts. So we have talked about appenders, how appenders work. It just provides kind of output destination. So layout is the main part or the crux which helps us format certain things in a certain way. So pattern layout, when we talk about this, so pattern layout has a very similar structure to C language. So if you have talked about like %f number, floating point number, %d as a digit, %s as a string, and all stuff, it is basically similar in the same format. So for example, think about this pattern here, right? So this is like percentage certain things, percentage certain things, percentage certain things, percentage certain things with certain things, and percentage certain things and certain things, right? Let's take a little bit of example to see this. What would be the output in this case? So this percentages -4 relative specifies that there are 4 positions, and relative specifies that is the time from the beginning of the program. So this is basically this. The percentage thread specifies which thread it is, and this templates provided a square box. That means the main thread is coming under a square box for that reason. Percentages 5 level or -5, that means it'll give total 5 length level of the log. That means debug or warn or error all will be max of 5, so we'll not see a difference. Here the logger or the logger name, and the 32 here specifies that it will limit itself to maximum of 32 characters, right? So manual.architecture.hello-world2 is the log that we have defined, and the hyphen comes as is, and we have the message. The message is hello world that we have, and the slash n defines the new line characters or the return character. So this is basically how you define the whole pattern. So when we talk about the console appender, so console appender had probably similar layout in this case. That is why when we just output like logger.debug with hello world, we could see the same amount of information in the first place, right? There could be other information like date, name of the threads and all stuff, but yeah, you got the idea. So now that we have understood about layouts, let's talk about logging now. So how logging works, or how parameterized logging works. Okay, talk about this example. So logger.debug entry number I and string.value of entry I, right? That means when we have to print this case, we have to convert this to a string. We have to convert this whole thing to a string as usual we're doing, and then only we'll be able to print it out, because eventually this has to be a string at the end of the day, right? So think about this. So if we are converting them into a string, we are using certain kind of computations to convert this to a string. And if it fails later that, okay, debug is not allowed because it goes below what is the level of the logger that is set, we just wasted a bunch of computations in that case, right? So that should be a way to avoid the computations of these cases in case those gets filtered out in the later part of the flow, right? So there is a thing called is debug enabled. So in this case, instead of directly computing the values of I and converting this to a string, it'll check whether the debug is enabled or not. That means it'll avoid the case that, okay, if debug is not enabled, I'll just avoid the computation. But think about a case, if debug is already enabled, then we're actually doing double computations. One, here we're computing that, okay, if debug is enabled, yes, it is, and that is what will return true here. And then we'll compute again for this case, right? So there should be a hybrid approach where it should help us identify that, okay, this in case of debug or no debug, enabled or not enabled, I should not use some kind of double computations or waste some computation. And that is where the parameterized logging comes into the picture. So look at this. So object entry with a new someday. So what we have is a debug parameter, but instead of converting them, we have parameterized it with an open curly braces. A pair of curly braces and an entry. So whenever this statement is executed, or whenever the debug state is finalized that, okay, this is something which is enabled, then only the conversion to string happens, and it saves a ton amount of computations, and we don't waste a lot of resources in that case. Okay, now we have an idea of logging, appenders, parameterized logging. So let's see how things work, or how things are stitched under the hood. Let's look at a little bit of architecture diagram. Okay, awesome. So we have the application. This was our Java program, or Hello World 1 or Hello World 2, which was firing the log request. Let's say we have firing the info request in this case, right? So we have this info request, and that lands first at something called a turbo filter chain. I don't know, we have not discussed about it, but think about this as a very specific filter which would figure out that, okay, if certain things need to be filtered right from the beginning before going all the way in the lifecycle method. So this is also the lifecycle of the whole log thing, how it works. Probably I'll just take it a little bit upwards. Okay, so this is the whole lifecycle, right? So your application, the logger comes in, the logger context, the logging event, attachable implementations, the appenders, and the layout. So it has to go through all of them. After layout, it is when we specify or we get the required string that needs to be printed. So excuse me. So we have this turbo filter chain decision. So it's kind of like a chain of decisions which needs to be evaluated before we make sure that whether we should move this log request to further down on the lifecycle methods. Otherwise, we are just kind of wasting a bunch of computations in there. So this turbo chain filtering decisions, what we say, it filters out events based on information like markers, level, logger, messages, or throwable. So any kind of thing like we have specifying that this should filter out this kind of levels, just filter it out. Don't let it go to the next levels. We have this marker or the trace marker, we would say. Don't let it out when we have certain kind of information in this marker. Don't let it out when we have certain kind of loggers, or don't let it out when you have certain kind of messages. It's like contextual thing. If you have certain kinds of information, probably sensitive information regarding to the customers, you can say that, okay, if this message contains some kind of 10-digit numbers or phone numbers or email addresses, please don't let it get logged at any places, right? That is something you can control with this. So this returns three states. One is accept, one is denial, one is neutral. So if it is accepted, it just moves to the next step. If it is denied, it's dropped there. And if it is neutral, then we can say that it is basically okay to move on to the next state. So the next state in this case is the check effectiveness level. This is kind of a same thing happening in the same place, but let's break it down for a little bit more clarity. So effective level is like whether the log request that is coming in is greater than equals to the log level that is set. For example, in the previous example, debug is greater than trace. That means if the request is of debug and the log level is set as trace, then we can say that the log level is enabled for this request. If the other way around, we'll say that, okay, this is not enabled, let's drop it. So in case of acceptance, it skips this process and goes to creation of the logging event. In case of denial, it just drops. In case of neutral, it has to check this effectiveness level and then it has to proceed. Okay, so after proceeding from this, if it is dropped, then no further actions needed. But if it is proceeded, then we can say that we are creating a logging event. So logging event is kind of like the primary construct which holds all of the context, thread information, messages, exceptions, or even something called as MDC. MDC is very interesting. So MDC is kind of stores some kind of contextual information for need to need basis, kind of that, right? So we'll say that we construct the whole logging event. Then we talked about appenders, right? So we talked about that each logger can have multiple appenders. It has to go in through a loop, figure out if the additivity is true or false, find the appenders from its parent and go on to find all the appenders and figure it out. That is why you see that loop on appenders is a state here. It will go to find all of the appenders, attach the appenders to this, and then it will be at this stage. This is very crucial. So to understand this, so we have all of the appenders ready. Now that we have all of the output destinations ready, we'll make sure that, okay, now that we'll go to the layout. But in certain appenders like socket appender and stuff, they don't need to go to the layout because they do the same kind of conversion to string or serializing things on their own. But in certain appenders, they need to go to the layout to get the actual formatted string at the end. So once this is done, this string is a resultant string that needs to be printed out in the output destination that we have in the appenders. And this is the whole life cycle of what happens when we just fire a logger.info request with some kind of bunch of strings inside, right? And that is how this whole things are stitched together so effectively. Awesome. Let's talk about performance. So now that we have talked about the architecture, the pros and cons and all stuff, let's talk about performance in this case. So performance when logging is turned off completely is pretty much a method invocation and integer comparison, because it'll just compare, nothing is enabled, and go forward, just go drop the request and move forward. It's a pretty cheap expense. It's like 20 nanoseconds on a 3.2 gigahertz Pentium D. Of course, so we are not talking about the parameter construction. So if there is a bunch of parameter construction getting converted to string, that'll obviously add up to the computation time. So performance of to log or not to log depends on the exact same situation as case one. It doesn't need to walk the whole hierarchy, is an instantaneous decision in that case as well. The main thing is the actual logging. So the actual logging can be broken down to two parts. One is the log formatting, which we say that, okay, format the logs if needed, or serialize it in case of socket appenders and all stuff, and sending it to the target destination. These are the major requirements, right? In states of a local machine, we would say that 9 to 12 microseconds is the average time in certain machines, like the machine that we have talked about, 3.2 gigahertz Pentium D. And if you're talking about remote logging, then probably it goes to milliseconds range, but it's pretty effective and pretty smooth in that case. Awesome. That's all I had for today, guys. And let me know if you like the video. Just hit the thumbs up button or subscribe to the channel. We'll have a lot more interesting sessions coming up. Until then, if you have any questions, please let me know. See you otherwise in the next one.